Hey guys, today we're gonna talk about the parabola. In math class, do you ever find yourself wondering what is a parabola? Or what are its properties? Or how do you get its standard equation? Or its general equation? It's also confusing. Well, don't worry, we're here to answer all those questions.
I am Cairo John.
And I am Krisha Kate.
I'm Godwin.
And I'm Jose.
I'm Steven.
Let's get going, guys. We still have a lot to learn about the parabola. Now, what is a parabola? A parabola is a set of all points P at x and y in a plane equidistant to a particular line directrix and to a fixed point focus. It is generated when the cutting plane is parallel to the side of the cone. So this is how it looks like. The distance from the focus to this point and the distance from the directrix to the same point is equal. This is where the parabola is in a cone. As you can see, the cutting plane must be parallel to the side of the cone. Let's proceed to the graph of the parabola. This parabola is facing upwards. The vertex is found at point H and K, and the focus is at point H and K plus P. The directrix is at Y equals K minus P. This is the latus rectum. The latus rectum is equal to 4P. The axis of symmetry can be found at X is equal to H.
Hi guys, I am Cairo. You already know about the focus and the directrix, right? Now we're talking about the remaining properties of a parabola. First, the vertex VHK is the midpoint of the focus and the directrix, which is also the intersection of the axis of symmetry and the parabola. Second one is the distance from the vertex to the focus, which is equal to the distance from the vertex to the directrix, is called the focal distance. Next to that is the axis of symmetry is a line perpendicular to the directrix that passes through the focus and the vertex. And the line segment which endpoints are on the parabola passing through the focus and is parallel to the directrix is called the latus rectum.
Now we are going to talk about the equations of the parabola. The general equation. We can recall that ax squared plus cy squared plus bx plus ey plus f is equal to 0 is for the conic sections. In the parabola, it is either a or c is equal to 0. If c is equal to 0, it is ax squared plus bx plus ey plus f is equal to 0. If a is equal to 0, it is cy squared plus bx plus ey plus f is equal to 0. If c is equal to 0, the parabola opens upwards or downwards. If a is equal to 0, the parabola opens to the left or right. The standard equation of the parabola. If it opens to the right, it is y minus k squared is equal to 4p times x minus h. If it opens to the left, it is y minus k squared is equal to negative 4p times x minus h. If it opens upwards, it is x minus h squared is equal to 4p times y minus k. If it opens downwards, it is x minus h squared is equal to negative 4p times y minus k. As we can observe, we can see that the equation depends on where the parabola opens, if it's right, left, upward, or downwards.
Since we're done learning about the meaning, properties, and everything we need to know about the parabola, we must now try them out with some examples. Example number 1. For a parabola with general equation 2x squared minus 12x minus 10y equals 22, find its vertex, focus, directrix, axis of symmetry, opening, length of latus rectum, endpoints of latus rectum, and standard form of equation, then graph. For example number 1, we are only given the general form of the equation. That is why we can directly see its vertex and length of latus rectum unlike the standard form. That is why we must transform this general form of the equation to the standard form of the equation. To transform a general form of the equation to its standard form, here are a few steps to follow. First, we must isolate the terms with the x variable on the left-hand side and the constant term together with the term with the y variable on the right-hand side. Afterwards, we must now make the numerical coefficient of the term with the highest degree equal to 1 for easy solving later since we are going to complete the square. To do so, we must divide the whole equation with the numerical coefficient, thus giving us x squared minus 6x equals 5y plus 11. The third step is now completing the square. Since we have already made the numerical coefficient of the highest degree equal to 1, we will now proceed to adding the third term of the left-hand side. The third term is the square of 1/2 the numerical coefficient of the second term. The left-hand side will now be x squared minus 6x plus 9. Since we added 9 on the left-hand side, we must also add 9 on the right-hand side. This is to keep the equation equal. Now we have x squared minus 6x plus 9 equals 5y plus 20. Fourth step will be expressing the perfect square trinomial of the left-hand side to its square of a binomial form. Notice that the second term of the binomial is 1/2 the second term of the PST. For the fifth and final step, we must now factor out the numerical coefficient of y, giving us the standard form of the equation. Now that we have the standard form of the equation, it will be easy for us to get the other properties. For vertex, we just have to look at the h and k value from the equation. Hence, the vertex is at 3, -4. For the focus, we must know the orientation first. We've learned from Godwin that when the variable x is the 1 squared, the parabola is facing either up or down, and when 4p is positive, then it is facing up. This parabola must be facing upwards. For a parabola facing upwards, the focus must be above the vertex, having h as its x-coordinate and k plus p as its y-coordinate. To get p, we know that LR is equal to 4p, thus p for this case is 5/4. Then the focus is at 3, -11/4. For the directrix, since the parabola is facing upwards, the directrix shall be a horizontal line p units below the vertex. Then it's equal to -21/4. Opening of this parabola as mentioned multiple times upwards, and the axis of symmetry for parabolas facing downwards or upwards is x equals to h. For this case, x equals 3. The length of the latus rectum, as we know, is equal to 5, while its endpoints are beside the focus, thus they have the same y-coordinate, while their x-coordinate is h plus minus 1/2 the latus rectum. The endpoints of the latus rectum of this parabola is at 11/2, -11/4, and 1/2, -11/4. We already got the standard form of the equation. It's quantity x minus 3 squared equals 5 times quantity y plus 4. For the graph of the parabola, from the vertex, focus, directrix, axis of symmetry, and the whole graph.
Alright, that was a very good example. Now let's try another example, but it's more complicated this time. Example number 2. Write an equation in standard form with the given features. Parabola with vertex at origin, focus on the negative y-axis, 6 units away from the directrix. First, let's talk about the inferences. We all know that the vertex is at the origin, so the vertex is at the coordinates 0, 0. Next, the parabola is facing downwards because the focus is on the negative y-axis and the vertex is at the origin. Lastly, the distance from the focus to the directrix is 6. We all know that the standard equation of the parabola is facing down is quantity x minus h squared equals -4p times quantity y minus k. In this formula, h and k is the vertex of the parabola, while p is the focal distance. Our vertex is at 0, 0, so the formula becomes x squared equals -4py. To further understand, here's the graph for this equation. Our distance between the focus and the directrix is 6, which is equal to 2p. To find the focal distance, simply divide 6 by 2, which is 3. Now we know what p is, we substitute it on the formula, which will become x squared equals -12y. And there you have it. The standard equation of the parabola is x squared equals -12y.